Anyway, linear functions. So yesterday we just talked about regular functions, right? A graph can be a function without being linear. It could maybe be like a curve, right? Or maybe like a zigzag or something, okay? Linear, though, means what? What's a graph going to look like if it's linear, Dallas? Like it's going to be a straight line, right? So today we're going to talk about functions that are specifically straight lines. So a linear function is generally, I would say, 80% of the time in the form y equals mx plus b. You guys remember that from back in the day? So a linear function is a function whose graph is simply a line. So if you take a look at this picture here on the right, we have a nice straight line there. That is an example of a linear function. It could be going up and to the left, it can be going down and to the right, it could be horizontal, it could be vertical, it doesn't matter. But that is a linear function. It has what we call a constant rate of change. That means it's always going up or going down by the same amount each little box on your graph. A nonlinear function then is simply a function whose graph is not a line. Like this little curvy graph here, right? That is not a line. That is a function, because would this pass the vertical line test? Absolutely. We did that yesterday. We would definitely pass the vertical line test. So it is a function, but it's not linear because it's not just one nice straight line. A graph like this does not have a constant rate of change. Maybe it goes up for a little while. Maybe then it goes down for a little while. Maybe then it goes up a little faster. Maybe then it goes down really slow, right? It changes all the time. If you're looking at a graph, a linear function is simply going to be one that's not a straight line, right? But what if you have an equation? What if it gives it to you like in written form? What are things you should look for? Well, if your equation has things like exponents, like an x squared or an x cubed or an x to the fourth, that's not going to be linear. Is that better, Bailey? Oh, okay. You were just squinting. I wasn't sure. Oh, okay. All right, if it has a square root, that is not a linear function. X, I'm just putting X like generically. It could be any letter, okay? Or if your variable is on the bottom of a fraction, like 1 over X, that's also not going to be linear. That's going to be like a curved graph. If you see any of those things in an equation, it is not linear, okay? Fractions can happen. Fractions are okay, like a half, a fourth, a third, but you can't have your variable on the bottom of a fraction. That's a no-no for these. Okay, so we're just going to practice. This is very similar to what we did yesterday. We're going to practice identifying if something is linear or not. We're going to look at graphs. We're going to look at t-charts, and we're going to look at some equations. Jaden, sit up for me. So for number 1, we have a graph here. It's in this like V shape. It's this right here. Do you think that this one would be linear or nonlinear? Nonlinear. Now, ones like this throw people off because you go, but this is a straight line. But is the whole thing one nice continuous straight line? No, it goes down for a little while, then it turns and it goes up for a little while, right? That's not constant. So we would say nonlinear. And then just like yesterday, we're going to write a reason. We're going to say because it is not one constant line. Right? It's kind of made up of little lines, like one line going one way, one line going the other, but it's not one nice straight line. Can you go see it up here? Do you want me to turn off another light? It's okay? Okay. All right. And then for part B then, what do we think about this one? Here we have this graph here. Do you think that that would be linear or nonlinear? Linear. It's one nice straight line, right? So we would say linear because it is a constant line. Good. The picture ones are pretty easy to decide. Any questions about the picture part? Feel pretty good about the picture part? Okay. So then, what about if we have a t-chart? Remember, this is like our sideways t-chart, right? These are our x's, these are our y's. Now, how are we going to decide it here? Well, we can't physically see if it's a graph, right? But remember from yesterday, aren't all these just points? This is the point 3, 36. This is the point 6, 30, 9, 24, 12, 18. Now, we don't necessarily have graph paper laying around handy, so we don't necessarily graph them and then see. Instead, what we're going to do is, remember yesterday when we had to like look for our repeating x's to see if it was a function or not? Okay. This one, we don't have any repeating x's, so we know it's a function, but we need to take it a step further and decide if it's linear. Now, linear functions are nice straight lines, right? They go up or down by the same amount every single interval. So what we're going to do is see if these numbers have what's called a constant rate of change. Have you guys ever heard that phrase before? A constant rate of change. That means we want to see if they go up or down by the same amount each time. So we're going to look at our x's first and then our y's because they both need to be constant. So what we're going to do is kind of examine like the little spaces in between. If we're going from 3 to 6, are we going up or down? Up, how many? 3. So we went up 3. What that means is we want it to go up 3 every single time. If it doesn't, it's not linear. So what about from 6 to 9? Up 3. Jaden, sit up and pick up a pencil. From 9 to 12? Up 3. Right, so was this one, are the x's at least constant so far? Yeah, x's are looking good, but we got to check our y's too. So let's look at the y's. From 36 to 30, did that go up or down? Down how much? Yep, down 6. So that means we want all of our y's to go down 6. They don't have to be the same as the x's, just the x's have to be constant and the y's have to be constant. So from 30 to 24, what happens there? It goes down 6. What about from 24 to 18? It also goes down 6. Good. So were my x's constant? Were my y's constant? Yep. So this one is linear. So we would say linear. And our reason is because it has a constant rate of change. So linear, there is a constant rate of change. Okay. All right, good. We are going to look at part D together, and then you're going to try out E on your own. So let's go over and look at part D. So first, it's always good to figure out, is it even a function in general? Because if it's not a function in general, do we even need to waste our time deciding if it's linear or not? No, not really. So is it a function? Do any x's repeat? No, okay, so we're good on that part. So now let's check and see if it's constant. What happens to go from 1 to 3? Up 2. What happens from 3 to 5? Up 2. What happens from 5 to 7? Up 2. Okay, so the x's look good, but is it enough for the x's to look good? Nope, the y's got to look good too, so let's look at the y's. From 2 to 9, what happens? It goes up 7. What about from 9 to 20? Yeah, one goes up 11. And then what about from 20 to 35? That goes up 15. Were our y's constant then? No. So can this one be linear? No. So this one's just the opposite. We would say nonlinear. And then we would say that y does not, or doesn't, whatever, doesn't have a constant rate of change. So nonlinear because y doesn't have a constant rate of change. You got that down, Corey? Zoning. Questions, concerns? Okay, try out part E. Try out part E. Somebody tell me what's happening with the x's. Bailey. Yep, for our x's, each is going up 1. Excellent. Somebody else, what about the y's? Asia. They are going down by 2. Good. So then somebody else, was this linear, nonlinear, or in y? Y linear, Dallas? Very good. We would say linear because it has a constant rate of change. Excellent. Not too bad, right? Cool. All right, now, if you look at F, we have an equation. Okay, so now we have to decide, is this a linear equation or not? And if you look up at your list up above, linear equations need to be in the form y equals mx plus b, okay? M and b should be numbers. And there's a few things it cannot contain. And sometimes it's easier to look for those, okay? We cannot have exponents, so no squares, cubes, fourths, etc. We cannot have square roots, and we cannot have variables on the bottom of a fraction. So sometimes it's easier to look for the things we don't want, okay? So for part F, does this have any of the things we don't want? Are there any squareds in part F? Any square roots? Any variables on the bottom of fractions? No, so is this probably linear? Yes, and if you look, isn't this in the form y equals mx plus b? This is actually a perfect example of what a linear function should look like, okay? So this one we would say linear, and then our reason for the equations either is going to be it is or is not in the form y equals mx plus b. So for this one, linear, because it is in the form y equals mx plus b. Good. All right, so then go to part G. All right, so for part G, again, let's look for the things we don't want. Are there any exponents? No exponents, but are there square roots? Yes. Is that a problem? Yes. So is this going to be linear? No. So we are going to say nonlinear. And there are 2 reasons I would accept. You could either say it's not in y equals mx plus b form, or you could say there is a square root, okay? Or if you prefer, say not in y equals mx plus b form. Those are both Those are both good explanations. Either one is fine. So you could say nonlinear because there is a square root. Or you could say that it's not in y equals mx plus b form, whichever you like better. All right, let's go to part H. Now this is also a very good example of, does this right away, if you look at it, is it in y equals mx plus b form? No, but let's look for the things that we know we're not allowed to have. Are there any exponents? No exponents. Any square roots? No square roots. Any variables at the bottom of fractions? No. So could this actually be in y equals mx plus b form? It actually can, it's just rearranged. It's just like not in the right order. Do you guys remember when we did our 2-column method to do our, like, rearrange our equations? If you look at this problem, we could actually turn this into y equals mx plus b form. If you take a look, the 5x is actually just on the wrong side. The 5x is just on the wrong side here. If we did our literal equation, we could, remember, you can put your line down through your equal sign. If we want just y equals, should 5x stay or go? Go, and it would become what? Negative 5x. The y would stay, and the negative 9 would stay, and now is this fixed? Yeah. So things can be linear equations without necessarily just being in that exact order of y equals mx plus b. Okay, so that's why it's sometimes a little better to look for the things we don't want. So we are going to say linear because it can be written in y equals mx plus b form. So linear because it can be written in y equals mx plus b form. Good. Okay. Anywho, we're back. We're on the back of our notes. Okay. So something that we talked about. Ready, Corey? Freaking take your earbud out for me. Thank you. Something that we talked about at the end of last class, but we ran out of time a little bit, was independent versus dependent function, or not functions, but independent versus dependent variables. So remember, independent variables, those are your x's. You get to decide whatever those are, right? Like, I think the example we looked at yesterday was like a bottle of juice and how many gulps you take, right? You get to control how many sips of your drink that you take, and then that's going to make the amount of liquid in the bottle change. So independent was your number of sips, and then the amount of liquid in the bottle was the dependent, right? Because one changes the other. So in this problem, we're going to talk about using input-output tables, which will be helpful for tomorrow. And it says the function y equals 2x plus 1 represents the cost y of playing a video game or playing an online game for x days. So y here is the cost. And then it says x is the number of days. It wants us to decide which is the independent and the dependent variable. Now, in general, independent is always x, dependent is always y. But what if it used different letters or something, right? Then you can't really use that. So you got to think about what it also means. Well, think about what you get to decide. If this is you, do you get to decide the number of days you play, or do you get to decide the cost? You get to decide the number of days you play this game. The more days you play the game, what's going to happen to the cost? It's going to go up, right? The less amount of time you play, the lower your cost will be. So do you think that independent would be days or cost? days, because you decide that, right? So independent is X days. Okay. And then dependent would then be what? Cost, because doesn't the cost change depending on the number of days, right? It depends on the number of days. So that would be Y, which is the cost. All right. Except my cost, my S does not look like an S. There we go. That's a little better. All right. So then if you rent the game for either 1, 2, 3, or 4 days, make an input-output table to find the possible costs. So input-output tables means you're plugging in an X and then you're going to solve to get a Y value. You're welcome to use a calculator on this if you want. It could be helpful. Okay, our numbers aren't very big, but it's good practice. So if you need to grab a calculator, go ahead. Oh, and Hayden, if you ever need to borrow a calculator, you're welcome to borrow one. Just when you're done, put it in the box so I can sanitize them later. Okay, so it says you rent the game for either 1, 2, 3, or 4 days. And if you look up above, isn't days X? So that's what you're going to plug in. So I'm going to put 1, 2, 3, and 4. And I'm going to give myself some space so I have some room to work here. Okay. So now what we're going to do is plug these values into our equation. We were given the equation y equals 2x plus 1. Okay, so this is our days. We're going to plug it in to get y, which is our cost. So basically what we're going to do is find out how much it costs to play this game for 1 day, 2 days, 3 days, 4 days. Okay. So now when we plug this in, there's I don't want to necessarily say like good and bad ways to plug these in, but there's ways that you can do this to make sure you don't make mistakes, especially when you have like negatives at some point or things like that. Now your equation was 2x plus 1. So we're going to take these numbers and plug them in for x, but here's what I want you to do. Instead of, when we write this problem down, instead of writing x everywhere there's an x, I want you guys to get in the habit of putting an open set of parentheses, because that's where we're going to plug numbers into. So if your equation is 2x plus 1 for this first one and line it up with your 1, we're going to put 2 and then an open set of parentheses plus 1. Okay. Now the reason we're putting that open set of parentheses is because it's like an empty spot in your equation, right? That's where we're going to plug our value in. And what's the first value that we're going to plug in? 1. So in that empty space, I want you to then put a 1. And now we're going to simplify. So we can use our order of operations here. What's 2 times 1? 2. So then you have 2 plus 1, and what's 2 plus 1? 3. That's okay. All right. Then for the next one, we're going to do this exact same process. 2, put your open set of parentheses, plus 1. Okay. What's the next value we're plugging in? 2. Okay. Now use your order of operations. What's 2 times 2? 4. So then 4 plus 1 is 5. You can all tell me. Don't be shy. All right, so now, okay, so what this then means, guys, is if you play for 1 day, how much are you paying? $3. If you play for 2 days, how much are you paying? $5. So now let's figure out what it is for 3 days. So you're going to do 2, put your open parentheses, plus 1. So then plug your 3 in. Okay, now order of operations. 2 times 3 is 6. 6 plus 1 is 7. So for 3 days, you pay $7. And then last one is 4. 2, put your open parentheses, plus 1 equals, and we're going to plug in 4. What is 2 times 4? 8. And then 8 plus 1 is 9. I don't know if you guys noticed, but what happens to the cost each day? It goes up by 2 each day. Okay, that's something we'll be looking at soon. Just something to notice. Okay, so here's our input-output table. We found all the possible costs, right? At 1 day, it's $3, 2, 5, 3 is 7, 4 is 9. Now, it wants me to find my domain and my range, and it says write as a list. Remember, for domain and range, if we have points, we do a list. If we have a continuous graph, we do an inequality. We don't have a continuous graph here, right? But we do have a t-chart. And isn't a t-chart just technically points? So if you look up at this table, these are all technically coordinate points. So if you look at like our first one here, 1 goes with 3. This is technically the coordinate point. What color is that? That's okay. This is technically the coordinate point 1, 3. That's technically what that means. Okay. Then for this next one, we have 2 with 5. How would I write that as a coordinate point? 2, 5. Okay. Then x was 3 and y was 7. How would I write that as a coordinate point? 3, 7. And then the last one was, I need a different color, 4 with 9. How would you write that as a coordinate point? 4, 9. Right, so it's really similar to what we did yesterday, just a slightly different layout. So if I have a bunch of coordinate points, can I write my domain? Can I write my range? Hopefully, right? Your domain is just all your x's, which we have over here, or if you like to write them as coordinate points over here, and then all of our y's. So for your domain, remember these are all your x values. So do your best to put your little curly parentheses. You awake back there, Aaron? So what are all my x values, guys? Jaden, you doing anything? Your paper looks really blank to me from right here, which is unfortunate. Yeah, 1, 2, 3, 4. 1, 2, 3, and 4. Make sure you separate with some commas, or else it just looks like one giant number. 1, 2, 3, and 4. All right, then your range, remember, is your y values. So then what are my y values, Olivia? Yep, 3, 5, 7, and 9. Good. I know, they're not very good. I'm not good at writing them in general, so then like with the stylus, it's even worse. Yeah. Okay. Questions on that? All right. Last thing then is we're just going to practice writing our domain and range as inequalities again. So the first one, right, was list. Now we're going to look at an inequality. So it says the function y equals 3x plus 50 represents the cost y of your monthly phone bill if you talk for x minutes. So we have the cost y, right? That's your y value. If you talk for x minutes. So we have to use that information to decide which one is independent and which one is dependent. So y equals 3x plus 50 represents the cost of your monthly phone bill if you talk for x minutes. Which one do you think is independent? Which one are you deciding, Aaron? X is independent because you decide the number of minutes you talk, right? That's your decision. So we're going to say independent. That is x minutes. And then for your dependent, dependent would then be what? Which one changes depending on the number of minutes you talk? The cost, yeah. So y, which is cost, right? What's going to happen the more you talk? Cost is going to go up, right? Exactly. Okay, so then this part B says, you know, you'll talk for up to 30 minutes. Using this information, write the domain and range. This time it's going to be an inequality because what does anyone notice? What's the key word in this problem that says, hey, this should be an inequality and not just like set values? Anyone notice? Well, yeah, besides the part where I actually tell you to write it as an inequality. Annalise, I heard you were saying something. Yeah, this part here that says you'll talk for up to 30 minutes. Is that necessarily like just one set value? No, maybe you'll talk for 25 minutes. Maybe you'll talk for 25 and a half minutes. Maybe you'll talk for 3 minutes and 30 seconds. I don't know, right? So that's not just set values. So what we are going to do now is we are going to write this as inequalities. So when you do your domain and ranges inequalities, remember, give yourself the little fill in the blank to work with. So for your x's, remember that's your domain. It says you can talk for up to 30 minutes. So could you talk for exactly 30 minutes? Could you talk for less than it? Yeah, absolutely. So we're going to use less than or equal to signs here because we could talk 30 minutes. It could equal that or be less. So I'm going to put my blank less than or equal to x, less than or equal to blank. So we want to find out what's the least number of minutes we can talk and what's the most number of minutes we can talk because x is minutes. Well, do we already know the top limit of how much we can talk? What's going to have to go on the right? 30. It says because that's the biggest we can go. Well, what would be the lowest? 0. Yeah, 0. Because can I talk for negative minutes? No, but could I I don't know, talk for just like 30 seconds? Sure, but I can't go less than 0. You can't talk for negative minutes. 0 is the least amount. Maybe I don't even pick up my phone at all, right? Not likely, but you never know. Okay, so there is your domain. But now for our range, that's y. This part's a little trickier. Because range is y, that's our cost. And we weren't told what our cost is. But if we're not told what our cost is, could we figure it out? Sure, we have an equation. We could figure it out using our equation, 3x plus 50. This is kind of like some of those problems we did in chapter 1 where it's like $3 per minute plus like a $50 fee. That's kind of like what these are. So we're still going to we're going to use our same structure here. We're going to have our blank less than or equal to y less than or equal to blank. We just don't know what to put in the blanks. But we have an equation and we have some numbers to work with. So how this kind of works is this is your range is your cost in this problem. So this is like the least amount you could pay. This is the most you're going to pay. Well, you're going to pay the least if you talk 0 minutes, right? You're going to pay the most if you talk 30 minutes. So could I take 0 and 30 and plug it into my equation? And that'll kind of tell me what my numbers are. Because again, I have my equation. If I plug in 0, that means I'm not talking at all, and I could figure out my cost anyway, because they're going to still charge you just for having the service. But then I could also plug in 30 and figure out what the most I could talk is. So I'm going to make myself another little T-chart down below here, kind of like what we did up in part 1. It's just a good way to organize your information. And I'm going to put X and Y. All right, so then the question is, what numbers do I need to plug in? I need to plug in 0 and I need to plug in 30 because maybe I talk 0 minutes, but I could talk up to 30 minutes. So I'm going to plug in those values. So we're going to use the exact same strategy we used in number 1 above. The equation it gave me, if you look up at your problem, it's y equals 30x plus 50. But instead of x, we're going to put some blank parentheses, okay, just like before. So this is going to be 3. Put your blank parentheses plus 50. That's what it looks like up above. Okay. But what's our first value that we're going to plug in here? Instead of parentheses, what are we going to plug into them? What number? 0. Okay, then let's use our order of operations. What's 3 times 0? 0. What's 0 plus 50? 50. That means 50 is the least amount I could pay. That's like your, I don't know, your service fee, right? Something like that. They're going to charge you that no matter how much you talk. So now let's figure out what it is for 30. So put your 3, put your blank parentheses plus 50. And then this time we're plugging in the x value, which is 30. You might, I don't know if you guys know. Do you guys know what 3 times 30 is? 90. Oh, look at you guys go. Okay. Yep, 3 times 30 is 90. 90 plus 50 would be what? 140. Good. So that is the most they could charge you. So now I know the least and the most. So put the least on the left. That's the least you might pay. And the most you might pay is 140.